Guys, if you can turn to page 4 of your packet. We'll do a quick review. We need to talk about intervals and changing the period of our functions. And hopefully we can start review, but if we don't get to review, you can try it on your own later, and also we can spend some time at the beginning of the class doing it, and then taking the 20-second half of it.
Every time I see it, it's always just talking to me. So it's like she moved.
Yeah, she did.
Like you, I feel like I don't know, I really sound.
Okay, guys, page 4. We ended with number 2 at the bottom here. So we talked about how we're going to build our sine and cosine graph the same way every time. So we're always going to start off at 0, and then we're just doing the quadrant radian measure. So pi over 2, pi, 3 pi over 2, 3 pi. And sine is going to start at 0, rise up to 1, and then make its way down and back up to 0. So we're always going to start and end in the same y value for the sine. And same with cosine. Cosine, we're going to start, but it's the shape of a cup. So it's going to start high, make its way down, and rise up again. Now, the way and we always want to start off with our original y values, because if there is a change in amplitude, we can make that adjustment by multiplying with our original y value. Okay. So we're going to now talk about what happens if our graph is either stretched or compressed. We're still going to have 5 slots, but now we're going to have to adjust our intervals because our graph is now stretched or compressed. So let's go to page 5. So we define the period of a graph as the cycle length of a graph. Now we know that the a value, which is the coefficient in front of the sine and cosine, is going to impact the height or the amplitude. But now the variable that's inside the sine and cosine, the b value, this is the coefficient of the angle measure inside the sine and cosine. That's going to determine the change to the period of the graph. Okay. So the a value is in front, and b value is that coefficient inside the parentheses, okay, or inside the trig function. Okay. So here's the formula. The period of or the new cycle of your function is going to be 2 pi divided by b. 2 pi represents the parent cycle, and then the b is the adjustment that's going to it's going to be the change that's going to impact the period. So it's 2 pi divided by b. And if I rearrange this equation, I can also say b is equal to 2 pi over p. But I usually just rely on this equation, and if I need to rearrange it, I can always rearrange it afterwards. Now, once we determine the period, we always divide the period by 4 because we have intervals of 4. So if we discount the first term here, we have 4 intervals, so we want to be able to spread out our interval. Our interval is not always going to be by pi over 2. It could be smaller, it could be wider, but we're going to always separate into divided by 4, which will give us 5 subintervals. Right? So that formula, that interval, that's going to help us determine what to put in each slot is p divided by 4. It's the new period sliced into 4 subsections. Okay. So I'm going to help us see how that's going to look. Okay, so let's look at let's look at number 3 here. Sine of 2 theta. Looks like our a value is not going to change, it's still 1. But in this case, what's our b value? 2. So it's going to be b value is 2. That's going to end up either shrinking or stretching our graph. So we're going to make some adjustment. So our period is going to be 2 pi divided by b. So our original parent period is 2 pi, but we have a new b value divided by 2. So now what is the full cycle of our sine function? Or period this way. That's pi. So that means it's going to be a smaller period, right? It's going to race through its cycle a lot faster than before. It's going to complete its cycle in just pi distance instead of 2 pi. But we want to make sure that we support our subintervals to make it easier for us to graph. So our interval is taking our period divided by 4, right? So p divided by 4. So our interval is going to be pi over 4. Before, our interval is pi over 2, right? We keep adding pi over 2 to reach our next subinterval. Now we're going to keep adding pi over 4 to reach our next subinterval. Now, for now, we're always going to start at 0. And we're going to keep adding 1/4 pi until we reach the end. And when we reach the end, we should be matching the length of the new period. Okay, so 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4, which is the same thing as pi over 2, right? But I'm going to reduce it, but I'm going to still keep that 2 over 4 in my head. 2 pi over 4 plus 1 pi over 4 is 3 pi over 4. And then 3 pi over 4 plus pi over 4 is pi. 4 pi over 4, which is pi. And this should always match, okay? Assuming we're starting at 0. Okay, but for now, it's going to always start at 0. Well, we know how the sine graph looks, right? The sine is going to start at 0, rise to 1, back to 0, -1, 0. So that's nice. That means we can keep our target y values the same. We're just adjusting our x values a little bit. Do we have any amplitude to multiply by? No. So our parent amplitude values will stay the same. Okay. So now our graph will look a lot alike from before. Okay. It's going to look pretty much the same as what we had before. It's just that now we are creating a new subinterval. Technically, it's shorter, but we can define our graph however way we want to. So pi over 4, pi over 2, 3 pi over 4, and pi.
Can you get the bottom part of the table again?
Okay, how do we get the bottom part of the table? Well, we know how the sine graph looks, right? The sine graph is going to start at 0, rise up to 1, back to 0, -1, and 0. So it's still the same sine graph. We're going to keep the same y values. We're just forcing the x values to change. Okay, so now we can just plot our order pairs. And then make it go in the negative direction as well. So it's like a mirror image, right? You're just taking this graph and you're just kind of folding it over. Well, in terms of the x values, but yeah, the graph will look a little different, but still the same shape. Any questions there? Okay, number 4, y is equal to cosine of theta over 2. Anybody know what the b value here for number 4? Good. So if it's hard to see, you can force that 2 to come out in front and make it 1/2 theta, if that helps. Right. Theta over 2 is same thing as 1/2 theta. And if you want to write it that way, you're more than welcome to, because it's easier to see that, oh, my b value is 1/2. Okay. What's the formula for finding the new period? 2 pi divided by b. Now, dividing by a fraction is same thing as multiplying by the reciprocal. So 2 pi divided by 1/2 is same thing as 2 pi times 2, which is 4 pi. So that 1/2 is going to end up stretching the period. So it's going to take a little bit longer, twice as long actually, for this period to complete its cycle. And we know the full cycle is 4 pi, but we want to split up into the subintervals. So what do? Yep, always divide by 4. So we're going to start at 0, and we're going to keep adding the interval until we reach our period. So starting at 0, we're going to keep adding pi. 0 plus pi is pi. Next, 2 pi, 3 pi. How does the cosine graph start? At 1 starts at the highest point, and it's make its way down to the lowest point, and then rises back up. Do we have to make any adjustments with the amplitude? No. The a value is 1. There's no adjustment. So pretty much it looks like our cosine graph. It's just that we've changed the interval. So technically it should be stretchier, but as long as we name our interval, that's more important. Sorry, this is 0, my bad. Yes.
So why on the positive side is like the line connected, on the negative side it's like dot?
Oh yeah, you don't have to. I just wanted to kind of show that the cycle can continue. The full cycle is from 0 to 4 pi, but I always want us to do one on the left side. So we don't have to do a dotted. I just want to show that's the full cycle, but I want to extend it to the negative side as well. Yes.
Can you explain real quick how you know exactly where the dots go, like our points?
Good. So think of this as your x value. And think of this as your y value. So my order pair, my first order pair is 0, 1. Second order pair is pi, 0. 2 pi is got -1. 3 pi, 0, and 4 pi, 1. So just treat your first row as your x value and the second row as your y value. Yes.
Do you put errors in that?
You don't have to. I guess technically the graph should be continuing in both directions. So yeah, so technically it should be continuing, but I'm not focused on that right now. But yeah, but you're right. Technically the graph continues infinitely in both directions. Yes.
The period again.
Okay, how do we get a period again? So the period is based off of the b value. Okay, so once you get that b value, you're going to do 2 pi divided by b. Right, so the b value is the number that's attached to the theta. So it's hard to see with that theta over 2, but if I force that 2 out in front, theta over 2 is same thing as 1/2 times theta. And 1/2 is my b value. It's inside the parentheses, but in front of the theta. That's your b value. Good. Any other questions? Okay, so the next examples, we're going to put more things together. We're going to have change to the b value and change to the a value. So we're going to see our graph stretching or compressing. And then we're also going to see our amplitude changing, and then potentially even some reflection going on. So I want to we're going to put all this together now with the next examples. But good. Good questions so far. Any other questions so that we're all comfortable moving to the next thing? All right, so these next examples will be nothing new, but we're just putting more things together. Okay. All right, so example 3. The y equals -3 sine of 4 theta. What's our a value? Okay, -3. But we do know that the negative is different from the 3, right? The negative is going to do what to the graph? Reflect. And then the 3 is going to stretch, right? Okay, so keep that in mind. So our amplitude is just the positive version of the a value. Okay. All right, what's our b value? 4. Good. It's inside the sine, inside the trig function, but it's the coefficient of that theta. Okay, so we know there's a change to our b value, which means it's going to force the period to change as well. So what's the formula for period? 2 pi divided by b. So what's our new period? Pi over 2, or 1/2 pi. Okay, so it's going to be, it's going to race through its cycle and quarter the time. Okay, but that's the full length of the period. We still have to do what? We still got to split it up into 4 separate parts, right? So that we can plot all the points that we need. So how do we do that? Yeah, so we take our new period, pi over 2, divided by 4. Now, think of it this way. Dividing by 4 is same thing as multiplying by 1/4. So if I force that 4 up as 1/4, what's pi over 2 times 1/4? Pi over 8. Okay, so that's my interval. Okay, yes,
For this, are we gonna be able to use calculators?
no calculus, no calculus. But the numbers should be relatively easy to do. Yeah, yes.
Explain.
Oh, we got B. Okay, so the a value is the number in front of the sine, and the b value is the number in front of the theta. Good. Any other questions? Okay, so we're going to start at 0, and we're going to increment by what? Pi over 8. So we're going to keep adding 1/8. Okay, keep adding 1/8 until we reach, hopefully, pi over 2. Okay, so 0 plus 1/8 is 1/8, which is pi over 8. Pi over 8 plus pi over 8 is
Pi over 4.
2 pi over 8, which is pi over 4. But I'm going to keep that in my head. I'm going to keep that 2 over 8 in my head. Okay, 2/8 plus 1/8 is
3 pi over 8.
3/8. 3/8 plus 1/8 is
Pi over 2.
4 pi over 8, which is pi over 2. And that's a sign that you're adding correctly, because you should end with the full length of the period. Yes.
So for the quiz, do we have to memorize the period and interval formula?
Yes, we do.
Alright.
Yeah. So period is 2 pi over b, interval is p over 4. Good. And we'll definitely review it right before you take the quiz tomorrow as well. And you have to memorize the pattern of the sine, right? Sine starts at 0, 1, 0, -1, 0, and then your cosine is 1, 0, -1, 0, 1. Or if you think of it this way, the sine starts at 0, and then think of the cosine just starting with this number, second number, 1, 0, -1, 0, 1. And so basically, if you memorize the sine, just know that your cosine is the delayed version of it, right? And then you know from 0 it's going to end up at 1, so you know that's going to start at 1 and end at 1. So that's also helpful too. If you know 1, you kind of just shift it to get the order pair, or the y value for the other one. Okay, good. Any other questions so far? Okay. Now, Sine graph, we know how sine graphs looks. We're gonna change the amplitude or change the A value a little bit, but right now let's just build from our starting value. So 0, right? 1, 0, -1, 0. But this is not the true new function, right? What's going to happen to these numbers? Good. It's going to change because of our amplitude and our A value rather. Okay. So I got to take all these numbers and multiply by what? By -3. Okay. By -3. So it's going to do two things here. That negative is going to force the graph to flip, and it's going to make our graph stretchier. Okay? But we don't have to worry about all that. We just have to just go through and just multiply everything by -3. So anything times 0 is 0. 1 times -3 is -3. Anything times 0 is 0. -3 times -1 is 3. And then back to 0. So now if we're going to graph these ordered pairs, and you're now going to ignore the middle one because the middle one was just a stepping stone to get to that third row. Now that we have our third row, we're going to rely on our first row and our third row. Our first and third row will give us the ordered pair that we need. So make your tick marks. And I'm going to go up to 3 and -3. And then plot your ordered pairs. So 0, 0. Pi over 8, -3. Pi over 4, 0. 3 pi over 8, 3. And pi over 2, 0. Make the negative version on the left. Okay. How does that look? Does every step make sense?
But it's like we have to do like the negative x-axis.
Yes, you got to do the negative side as well. Okay. So we're practicing the negative and the positive side. Okay. All right, so let's see if we can do one on our own, and that will kind of solidify how strongly we feel, or how comfortable we feel with this where we are so far. Okay, so number 6, find the A value, find the amplitude, find the B value, go through the period formula, go through the interval formula. So go ahead and try that, and then after a minute, I will follow up with the steps. And again, anytime I see a fraction, I always want to consider rewriting it, right? Sometimes if you rewrite it, it makes it easier to see that B value. Okay, let's check our progress so far. You can push that 3 in the denominator out in front of 1/3. So 1/3 is your B value. Your A value is the 2. So 2 pi divided by my B, 2 pi divided by 1/3 is the same thing as 2 pi times the reciprocal, 2 pi times 3, which is 6 pi. I take my period divided by 4 because I want to slice it into 4 separate parts so I can plot my points. 6 pi divided by 4 reduced to 3/2 pi over 2, which is 1.5 pi. So we're going to keep adding 3 pi over 2 until we reach 6 pi. Okay, so 0 plus 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, or 3 pi. Plus 3 pi over 2 is 9 pi over 2. And then plus 3 pi over 2 is 12 pi over 2, and that does take us to our destination of 6 pi. Okay, where does cosine start? The parent graph. Starts at 1 and make its way down to the lowest point and rises back up to its starting y value. But this is not the y value we want to plot, right? What do we want to multiply that by? 2, because our amplitude is 2, so I got to multiply by my A value to get my true height. So multiply all your parent y values by 2. Okay, so ignore the middle row. You're just looking at the first row and the third row. First row is your x value, third row is your y value. Okay, any questions here?
Questions or support?
3 questions. Very similar to that handout that you just got. Okay, so let's go to page 7, and I want to talk about looking at this from a different perspective, writing an equation. I'll leave this up here for a second. Page 7. Yes.
You have to write the negative as well.
Yes, I want you to do the negative side as well. Yeah. All right, page 7. So number 5, it says, write a sine function with an amplitude of 0.4. This one's pretty easy here because we just have to replace the A value with 0.4. And it looks like there's no change to the B value. We can leave that as 1. So y is equal to 0.4 sine of theta. Six, 7, and 8, they're all easy, right? You're just replacing all the A value with what they tell you the amplitude is. we'll do those quickly, and then I want to talk about 9 through 12, where we're going to be creating, see if we can create the function that we have in front of us here. Okay, number 9. Let's take a look at number 9 closely here. What function does that look like to you here? Sine starts at 0, rises to its highest point, and complete its cycle within 2 pi. So we know that the b value is not going to change. But what will change though? The a value, right? The a value, it only rises up to what? From 0 to 0.5. So we know that our a value is 0.5, and it's a sine function. So okay, we know it's sine function because it starts at 0 and rises up. All right, number 10, what does that look like to you? Cosine. It does the period change? Yeah, still 2 pi, right? So we know that the b value is not going to change. But what will change is the a value. What's the a value here? 4, right? So from rest to crest. So basically from the center to the highest point. Okay, see if you can do 11 to 12. This should be pretty easy as well. Okay. 10 minutes remaining. Let's see if we can get through the odds on page 8. Okay. So we'll go through the odds on page 8. Yes, question?
Like on the quiz, like, you make a chart. You know how sometimes you can simplify the fraction? Do you have to simplify it?
You don't have to. Okay, so number 1 says state the amplitude and period for each function. Okay, so for number 1, guys. Yes, question? Your a value can be negative, but your amplitude is always positive. Okay. So for number 1 here, what's the amplitude for 2 fifths? Now we see a b value for number 1, so we gotta, what's our period gonna be for number 1? Yep, 2 pi divided by 9. It's only asking for the full period, so we don't have to divide by 4 because that's what we want to graph. Yeah. You don't have to simplify, and also here we can't simplify it. All right, number 3. What's the amplitude for number 3? Just 2.5, right? The a value is negative 2.5, but the amplitude is just 2.5. So let's build our period here. What's our b value? Good, 1/5. So we got that 5 in the denominator. Think of it as pulling that 5 in the denominator out in front, and it's going to is going to be 1/5 theta. Now our period is just 2 pi divided by 1/5. Dividing by 1/5 is the same thing as multiplying by 5. So period is 10 pi. Okay, so 5, 7, and 9, these are a bit more challenging because we have to work backwards to get to our b value because we want to write the equation of the sine function. So here's the sine function. Amplitude, that's easy. We just insert that 3 in for a, but here they're giving us the value for the period. So let's write the formula here. So period is 2 pi divided by b. So we're not going to insert this pi over 6 into b value. That's going to go in for the period variable. And then we're going to cross multiply and solve for b. Okay. So we're kind of working backwards to figure out what is the b value that causes the period to be pi over 6. So pi over 6 is equal to 2 pi over b. Cross multiply, and I can work my way to solving for b so I can insert into my equation. I can take pi away from both sides of the equation. What's my b value? B is 12, a is 3, so now I'm just going to insert them into my sine equation. Okay, does that process make sense? Yes. So you make a good point there. It can be, it says write an equation. So you can either interpret it as a -3 or a +3. But if you say plus or -3, that's fine as well. But it says write one equation. So if it's asking for all the equations, then maybe I'll do that plus or minus. But yes, good point. You can do a plus or a minus, and that will be sufficient. So in these problems, we have to work backwards, right? We gotta solve for b and do things a little bit differently. Okay, so let's see if we can try number 7. Let's finish up. Let's see, what time is it? Okay, a few minutes remaining. I encourage you guys to work through this practice review because this is going to be pretty much what your quiz will look like. But I have the key on the back, so you guys can see how well we can do. But tomorrow we will go through this at the beginning of class and then take the quiz right after that. Who will get your phone? If you need it.